Hello and welcome to another video on Progressive Coder. The topic for today, how to design a high availability system on the cloud. To begin things, let's understand the meaning of high availability. You call a system highly available when it can remain operational and accessible even when there are hardware and software failures. The idea is to ensure continuous service. So how can you design such a system? The most reliable approach is to leverage static stability. But before we get to the meaning of this term, it's important to understand the concept of availability zones. You must have heard about availability zones in AWS or other cloud platforms. If not, here's a quick definition of the term from the context of AWS. Availability zones are isolated sections of an AWS region. They are physically separated from each other by a meaningful distance so that a single event cannot impair them all at once. For perspective, this single event could be a lightning strike, tornado, earthquake, or even a Godzilla attack. To achieve this separation, availability zones don't share power or other infrastructure. However, they are connected with fast and encrypted fiber optic networking so that application failover can be smooth. In this picture from the AWS Global Infrastructure page, the orange circles denote a region and the number within those circles is the number of availability zones within that region. Availability zones let you build systems with high availability. However, you can do so in two ways, reactive and proactive. In a reactive approach, you let the service scale up in another zone after there is some sort of disruption in one of the zones. You might use something like AWS auto scaling group to manage the scale up automatically. But the idea is that you react to the impairments when they happen rather than being prepared in advance. In a proactive approach, you over provision the infrastructure in a way that your system continues to operate satisfactorily even in the case of disruption within a particular availability zone. The proactive approach ensures that your service is statically available. A lot of AWS services use static stability as a guiding principle. Some of the popular ones are AWS EC2, RDS, S3, DynamoDB, and Elasticache. If your system is statically stable, it keeps working even when a dependency becomes impaired. Maybe the system can't see new things or modifications that were provided by the dependency, but everything it was doing before the dependency went down continues to work. For example, the AWS EC2 service supports static stability by targeting high availability for its data plane, the one that manages existing EC2 instances. This means that once launched, an EC2 instance has local access to all the information it needs to route packets. However, leveraging static stability is not just for the cloud provider. You can also use static stability while designing your applications for the cloud. Let's look at a couple of patterns that use the concept of static stability. The first pattern is active high availability using availability zones, and here's an example of how you can implement it using a load balanced HTTP service. You have a public facing load balancer targeting an auto scaling group that spans three availability zones in a particular region. Also, you make sure to over provision the capacity by 50%. If an AZ goes down for whatever reason, you don't need to do much to support the system. The EC2 instances within the problematic AZ will start failing health checks, and the load balancer will shift traffic away from them. Since the setup is statically stable, it will continue to remain operational without hiccups. The second pattern is active standby on availability zones. The previous pattern dealt with stateless services. However, you might also need to implement high availability for stateful services. A prime example is a database system such as Amazon RDS. A typical high availability setup for this kind of requirements needs a primary instance which takes all the writes and a standby instance. The standby instance will be kept in a different availability zone. When the primary AZ goes down for whatever reason, RDS manages the failover to the new primary, the standby instance. Again, the service is statically stable. So what's the takeaway? In both patterns, you had already provisioned the capacity needed in case of an availability zone going down. In either case, you are not trying to create new instances on the fly since you have already over provisioned the infrastructure across AZs. This means your systems are statically stable and can easily survive outages or disruptions. In other words, your system is highly available. Over to you now. Does high availability matter to you? If yes, How do you handle it within your application? Write your replies in the comment section below. That's all for today. Don't forget to subscribe to Progressive Coder and press the bell icon to get instant notifications. See you later.